So the proposed bond is really about three things. Primarily is safety, but secondary is fiscal responsibility and efficiency. So we'll start with kind of more of the safety aspect of the project. And the current problem that the school has is that the front door is way down there and the office is way over here. So there's a lot of reliability on cameras, and then trust that once you let somebody into the building that they're going to go the proper direction. So there's a lot of concern about, you know, with the way the world is today, what could happen if somebody got into the building and then pretty much has free reign after that point. So the plan is to take the offices that are located down here and relocate them up to the front of the building so they'll have eyes on the door pretty closely. And we're actually going to build a piece out into this hallway so the reception desk actually looks straight at the front door. To make that happen, you need to move a critical mass of people down to that end and not just have an isolated person at the reception area. So the proposal is to take pretty much the entire office suite, move it up to the front half of the cafeteria, and move the front half of the cafeteria and relocate it back to where the current office suite is. So that's, you know, it's a fair amount of moving, and it changes mechanical systems and things like that. The specifics about how we're going to deal with safety is that the front doors would still be locked the way they are now, but there'd also be a secondary set of locks. So somebody comes to the front door, asks to come into the building, the receptionist will have eyes on them, and if they let them through the door, then they can come in and they can talk to the receptionist without coming out of the secure zone. And once they've had that conversation, and then they can be allowed through a second set of doors that can be unlocked from a button inside the office. So that really gives you pretty good control. In addition, there'll be locking on the upstairs doors that go over into the cafeteria area. So it's really going to be able to contain that front lobby area pretty nicely. There's a small piece of adding a concession area on the second floor because the fire marshal does not like the fact that they're selling food out in what is basically the egress path from the gymnasium. So that's a pretty minor piece of the project, but just to deal with that code concern at the same time. So that really moves the front office all the way up there, so there's good double coverage, there's good eyes, that there'll be windows that look out onto the hallway in multiple directions. So I think it's going to be pretty beneficial there. So that's kind of the real safety piece of this. The others are not quite as exciting, and you won't really see them as much, but the second piece is that there's one of the three boilers that exist is not operational and needs to be replaced in some manner. So everybody started looking at the option of using locally sourced fuels. And when the bond vote was done back in 2000, there was a hope that there would be a wood chip system. That wasn't able to happen at that time. So what we're actually looking at now with the newer technologies is that you can do a wood pellet system that can also burn what is called dry chips. So they're a lot like the wet chips that have been used in many schools around the state, but they're actually kiln dried to a drier point, so they can actually be burned with the same boiler as a wood pellet boiler. There wasn't enough room to actually physically put that boiler in the existing mechanical room, and we can go down and look at that. So the proposal is to build a new boiler building over between the access road and the ball fields on that slope to hold the new wood pellet / wood chip boiler, and put the silo that holds the fuel immediately adjacent to that. And what that will really do is that will allow the school to burn what is ever the most cost effective at the time. There's also less concern about if one fuel source isn't available, you have another fuel source out there. So there's really going to be three options that you can do. You can either do chips, pellets, or the oil that's currently being used. And so it's really gives them a good mix of how to deal with that. Third component is the building mechanical controls are now 20 years old, and they're actually operating in reasonable condition, but pieces are starting to fail, and the real problem is that the company that originally put it in is no longer the authorized company for the components, so they had to get somebody from out of town to put in some different components, and they don't talk to each other, and it's going to be a bit of a cobbed together system. So really 20 years is a pretty good expected life for a control system anyway, and with the newer technologies there's a lot more efficiency that can be wrung out of these things. They can be dealt with remotely, so Patrick can actually deal with issues without having to come to the school. He can check heating points and everything from his home or his phone, so there'll be some efficiencies there. And the fourth component is that, again, 20-year-old school, pumps and fans and many components that operate the building fail over time. So what they do is now, at this point, when something fails, they'll get a new one, they'll fix it. It's disruptive, it's inefficient because they don't have the parts on hand, because you don't really know what's going to break. So we've gone through and done an assessment of the items that are likely to fail in the next year or two, just based on past history of similar items like this, and looked at the ones that have already been replaced, and really gone through and done an assessment to make sure that we are looking at replacing things that we think will fail soon, so that they can come in, have a company come through, replace all these, and then the maintenance staff can really concentrate on the things that they're supposed to be doing day to day, and not have to do an emergency repair of this and have a classroom that's cold, or disrupt a classroom because they have to get in there to fix something. So it's really just it's a way to be more efficient and allow people to do the items that they're typically supposed to do. So there was a follow-up question about the existing boilers. I don't think I explained that very well. There's currently 3 boilers, 2 of which that are working. So the way we typically design buildings is that on all but the very coldest of days, you should never have to fire more than 2 boilers at one time. So as it currently stands, on all but the 3, 4, 5, whatever the winter's like, coldest days of the year, the 2 existing boilers will keep up. There are going to be a few days every winter where it's going to get a little cold inside the building because they can't quite keep up, and the real issue is that if one more boiler goes down, you're really not going to be able to keep up. So we do build in redundancy with these systems, but one boiler has failed. So something's going to need to be done. Either a boiler is going to have to be replaced in an emergency situation if one more goes down, which makes it much more expensive, and these aren't just off the shelf anymore. These are big boilers. They're made to function for a whole school. So it really seemed like a good opportunity, instead of replacing that existing oiler boiler that's failed, to put in a new wood chip and pellet boiler. So the plan is to actually put the wood chip building right here. The front doors would be roughly right about here. And then it would fit between here and the fence at the bottom. And then the pellet silo would actually sit right where that little birch tree is, pretty much. It's a 19-foot diameter silo, so it's got a lot of capacity. Deliveries would be made off hours, so there wouldn't be any concern about deliveries with interactions with kids. But it maintains all the functional play space around the building. We looked at 2 or 3 spots over there. We looked at one tucking it back in here. We looked at a whole bunch of spots. We arrived here because it didn't really touch any of the swing area, the play area, the octagon. We actually looked at a spot down near where the octagon is as well. It allows snow plowing to still happen very easily, so it really seemed like a good spot because we weren't impacting things very much. As part of that, we'd put another set of stairs that goes down, that comes straight off from that doorway, so that we wouldn't have to go, as currently you have to go over, down, and across, so it'd be a more direct path to the ball fields. And then some fencing reconfiguration to kind of keep people where they should be and away from the building. So the boiler building would be using a lot of the same materials that are on the school, so good, durable, long-term materials of masonry and metal. And the boiler silo the pellet silo is really nothing more than a really large metal silo, 19 feet in diameter and probably about the same height. But that will feed all the fuel directly into the boiler building through an auger and into the boilers. So this is the boiler room that was added into the project when it was realized that the wood chip portion of the project was not able to be funded back in 2000. So this boiler here on the end looks exactly like the other two, but does not work. So this is the one that needs to be replaced in some manner. There was a question about how the heat from the wood chip or pellet system works its way into the building, and it was actually a pretty good question. So heat will be generated out in that building, and then there's hydronic pipes that will bring hot water into the building. And there was still hope that someday the wood chip system that was designed was going to be able to be part of the project. So we actually ran pipes that you can see here that have been headed off and head out and can be tied back into the outside. They're run pretty much to the outside wall, or maybe just outside the wall actually. So we're going to connect into those. And that's how all the hot water from out there comes and combines with the hot water that's generated from these boilers and can combine into a single system. So really this will remain a boiler room. The only real change that you're going to see in here is that there might be a couple of extra pumps and things that serve what's going on outside, and this boiler will disappear.